Today we are going to focus on subtracting positive and negative fractions. But before we do that, I want to review subtracting integers. I need us to remember that when we are subtracting integers, we actually add the opposite to make our lives a little bit more simple. So I rewrite my problem. So my -7 is my first part, and that stays the same. But then what happens is I take that and I switch that to addition, and then I add the opposite. So the opposite of +15 would be -15. Now I follow my adding integer rules. So -7 plus -15, if I have two negatives, that'll get me that -22. Here, same thing. I keep my first number the same, but then I turn my second number into addition, and then I turn my symbol into addition, and then I go ahead and say, okay, what's the opposite of +4? Well, it's -4. 13 plus -4 will get me +9. Here again, keep that first number the same. If you don't want to rewrite the problem every time, you don't have to. This one's a simple one. Keep that the same. Add the opposite. The opposite of -6 is +6. So if I have -6 plus +6, that'll get me 0. Here again, I've got 10 minus -4. If I keep that 10 the same, turn the symbol into addition, and determine the opposite of -4 is +4, I will get 14. Lastly, I've got 8 minus -8. If I keep that 8 the same, turn my symbol into addition, opposite of -8 is +8. 8 plus +8 is 16. So I use those rules to help me today when I'm subtracting positive and negative fractions. The other super important thing that I need to remember is that I must have a common denominator. If I do not have a common denominator, I cannot subtract my fractions. So let's go ahead and give a few of these a try. 1/4 minus 3/4. So I'm going to go ahead and rewrite my problem here. Okay, since I have the same denominator, all I need to focus on here are my numerators. But in this case, that means that I need to turn this into a positive. And the opposite of +3 is -3. So now I'm left with 1 plus -3. That's going to get me 1 positive and 3 negatives. -2. Denominator stays the same. -2/4. I can simplify that down by dividing both of those by 2, getting me -1/2 as my final answer. Going on to the second one, again, I'm going to rewrite my problem for myself, attaching that negative to my numerator. So I want that negative to stay with my numerator. This first stays the same. My first problem stays the same. Again, since I already have denominators that are matching, I focus on my numerators. This stays the same. This flips to addition. And then I find the opposite of -2. The opposite of -2 is +2. So now I just go ahead and add like I normally would. -4 plus -2 is going to get me -2. My denominator stays the same, so I've got -2/5. Here again, let's rewrite it. I have the common denominator, so I can just rewrite as is. Attaching that negative, I want that negative to attach to my numerator. I can go ahead and focus on my numerators since my denominators are already the same. And I go ahead and add the opposite. Flip my symbol to addition and find the opposite. So Opposite of -1 is +1. Here I take 5 plus +1, getting me 6. Denominator of 6, 1 whole. So 5/6 minus -1/6 is going to get me 1 whole. Down here, we've got some practice where our denominators are not the same. So once we get our denominators to be the same, our process will be just going ahead and adding the opposite. But first, we've got to change our denominators. So I've got 4 and 2. I can list out my multiples if I need to. Otherwise, if I don't, I can go ahead and rewrite my problem. 3/4 minus 1/2. So this can stay the same. I'm going to keep that 4, but I need to turn this into 4. So I will multiply 2 by 2 because that'll get me 4. So I have 3/4 minus 2 times 2, the desired denominator is 4, but I have to multiply the numerator as well. If I multiply something with the denominator, I have to multiply it with my numerator. 1 times 2 is 2. All right, now I have the same denominators, so I focus on my numerators, and I add the opposite. So I turn this into addition, and the opposite of +2 is -2. 3 plus -2 is -1. My denominator stays the same. My answer here is -1/4. All right, moving on to this next problem. I've got 6 as a denominator and 4 as a denominator. So the very first thing I'm going to want to do is make those common. Again, I can write out my multiples if I need to. 12 is common, so I attach my negatives to my numerator. I don't worry about flipping anything yet. I know that I need to turn this. I want both my denominators to be 12. To get from 6 to 12, I multiply by 2. To get 4 to 12, I multiply by 3. 2 times -1 is -2. 3 times -1 is -3. Again, I keep my first number. I only focus on my numerators now since my denominators are the same. But I go ahead and turn this into addition and find the opposite of that. Opposite of -3 is +3. -2 plus +3 is going to get me 1/12. That's my answer. Last one for today. We've got 2 new denominators. Again, they do not match, so I need to go ahead and determine what I can use instead. So they are the same. I've got 10 here. So I rewrite my problem, attach my negative sign to my numerator. I know to get from 5 to 10, I have to multiply by 2. Since I multiply the denominator 2, I'm going to multiply the numerator by 2, getting me 6. My symbol stays the same for a moment as I continue rewriting my problem with my common denominators. To get from 2 to 10, I multiply by 5. Since I multiplied 2 by 5, I multiply my numerator by 5. Now, since I have the same denominator, I can focus solely on my numerator. Because it's a subtraction, I'm going to go ahead and turn this into positive. So we're going to turn that to a plus sign, find the opposite of that negative, which is positive. So now I've got 6 plus +5. 6 plus 5 is 11. My denominator stays the same. This is an improper fraction since that numerator is larger, so I can rewrite it as 1 and 1/10. So when we are subtracting positive and negative fractions, we want to make sure that we do have a common denominator, and we can fly through the rest. We subtract or add only the numerators. The denominator will stay the same. And then don't forget those subtracting integer rules.